In this video, I'm going to tell a story about large language models with a perspective centered around a paper that Thomas, Maeve, Mohammed and myself recently published. On the 30th of November 2022, ChatGPT was first released to the public, causing a lot of buzz online and in the media. But people probably didn't realize that ChatGPT was about to become a household name. I believe this was a truly historic moment, representing the first time that the people gained access to artificial intelligence. Fast forward 2 years later, and what did the people do with it? Well, they got creative and they went to the literature to find slurs for AI and robots. When ChatGPT was first released, I was spending a lot of time on coursework and research projects. Initially, I was very skeptical, so I put it to the test to solve an absolute classic undergrad physics problem, Schrödinger's equation for the hydrogen atom. I didn't get the outcome I wanted, which is what you see here on the screen. Today, ChatGPT would be capable of producing a program that generates something that looks like this. So after that first setback, I let it be for a little bit. But a few months later, a friend recommended I use it for coding. So I did and started to understand it more, and I could also see the model was improving. Then, talking with friends on the medical physics program, ChatGPT was brought up and it became very clear. Everyone was using it, myself included. And this got me wondering if this tool is also being used by clinical physicists and not just students. So I thought, let's do a survey and find out. First, I started exploring the research output for various key search terms in the PubMed database. What you're seeing here is the number of new publications per year between 1980 and 2024. More classical topics like radiopharmaceutical therapy and Monte Carlo simulations have seen a gradual rise in research output over the last 4 decades, whereas the output around ChatGPT and LLMs has seen a very rapid increase, catching up in just 2 years. So why the sudden surge in publications on ChatGPT and LLMs? First, if you have a mobile device that is connected to the internet, you have a state-of-the-art model. Second, the marginal cost per experiment is basically zero. No lab, licenses, or GPU cluster needed. This combination of accessibility and power is what turns curiosity into experiments, and experiments into papers. This new technology has broken down barriers to science. The survey was designed to capture LLM use in Australia and Aotearoa, New Zealand. The Australasian College distributed the survey via website, mailing lists, social media and emails, helping us to reach 101 responses. The survey was open for 18 days in February of 2025, and a custom medical physics t-shirt was used as an incentive to encourage responses. The survey asked about demographics and about how and which LLMs are used, their perceived impact and privacy choices. Now, on to results. From the first question, we see that about half of respondents were qualified medical physicists, followed by medical physicists in training and leadership, as well as a few other more niche roles. Next, we have the question on the number of years of experience in medical physics, which was defined as the number of years in medical physics-related higher education programs and/or professional experience. From these first 2 questions, we can see that we have captured responses from a well-established group of professionals. Regarding specialties, we found that about 60% of respondents specialized in radiation oncology. This is as expected, given that in Australasia, there are about 8 radiation oncology medical physicists for every 1 in diagnostic imaging. On to the questions about LLM usage. We start with the simple question. Have you used a LLM platform before? Almost 90% said yes. Next, we asked about alternative platforms. Although ChatGPT is the dominant platform, respondents also reported using Copilot, DeepSeek, Gemini, Claude, and many others. This question showed that many models are becoming available for public use and are being adopted by the community. We then asked about the frequency of use of LLMs, and we found that more than 75% of physicists use LLMs regularly, with some even using them daily. Clearly, these tools have become essential for some. Next, we asked about the usage of paid platforms. For this one, we actually found that few physicists use a paid version. This shows that although adoption is there, many are satisfied with free versions, or employers have not deemed them worth paying for just yet. Regarding the tasks which physicists use LLMs for, we can see that the possibilities really are broad. Most commonly, LLMs are used for professional use, education and learning, and coding. But they've also been used for creative tasks, research, admin, translation, and even business and marketing. So LLMs are exploited by medical physicists for a broad range of tasks. Now, looking at the question on data privacy, which is whether people are opting in to improve the model for everyone, effectively allowing the platform to use their data to train models, we have an interesting result. There are roughly as many respondents that do not opt in as there are that do not know what their choice is. We can also see that a few opted to share their data. Clearly, this is problematic. There is no consensus as to what the best decision is here. Finally, we have the questions on perspective. First, we asked if respondents expect that their colleagues use LLMs. And we found that almost 90% of respondents do expect their colleagues to use them, showing a growing awareness of this adoption of technology within the community. Now, when asked whether respondents believe that LLMs improve the efficiency of their work, more than 80% answered yes. On the other hand, when asked whether they believe that LLMs improve the quality of their work, the percentage that responded yes dropped to 60%. These two questions show a crucial point of perspectives. LLMs are not meant to be capable of doing our jobs better than us, but maybe they can help us get from point A to point B a bit faster, or maybe even a lot faster. So LLMs have been adopted by medical physicists in Australasia. These tools are extremely versatile and readily applicable beyond research. There's a greater perception of efficiency gains than there is of quality, and there are risks and ethical gaps that policy, training, and governance lag behind. There's no consensus on whether we should share our data with big tech companies, and maybe an updated and international survey would be useful. Large language models can accelerate our work through the automation of what Jeff Hinton would call menial intellectual labor. So can we justify not using LLMs? And who is advocating for our access to powerful models that will ultimately drive improvements in patient care? Thank you for listening, and as always, if you have any questions or queries, please reach out.